Good evening, guys. This is Mr. Holmes getting ready to talk to you guys about how to show that a binomial is a factor of a polynomial. Then we're going to factor that polynomial completely. Okay? Now, if you've ever watched any of my videos, you'll know to show that a binomial is indeed a factor of a polynomial. One of the methods we use is synthetic division. So today we'll be practicing using synthetic division. Okay, now notice in my binomial it reads x plus 4. Keep in mind that the binomial is written as x minus k. So the k value will always appear opposite of what it actually is. Because this number is positive, that tells me that my k value must have been a negative number. In this case, negative 4. Now, because we're using synthetic division, we ought to know that the first term starts us off by bringing this term straight down. So in this case, we have the number 1. And from here, we will multiply negative 4 times 1, and this will give me my negative 4. We will always add in the middle. 4 plus negative 4, this will yield 0, and we will repeat this process. Negative 4 times 0. Negative 4 times 0 will yield 0. We will add 0 plus 0, and we'll get just that 0. And we will repeat this process, negative 4 times 0. And we will get 0 here. And we will add negative 64 plus 0. And this will yield negative 64. We will multiply it one more time. Negative 4 times a negative 64. And this will yield a positive 256. We will add negative 256 plus 256. And we would get 0. 0 in this case is my remainder. So because it's my remainder, then we will say yes. Excuse me, my lights timed out on me. We will say yes. X plus 4 is a factor. Now that we determined that it is a factor, we must now go and factor out our polynomial. And to do this, we will rewrite this polynomial 1 degree less because we are dividing. We are dividing, and when you divide, we always subtract exponents. So here we have 1 exponent less. Instead of reading x to the 4th, this will now be all coefficients and constant to my new polynomial. So instead of x to the 4th, it will now read 1x cubed. No, this, let me just do this here. This will represent the coefficient of x cubed. This will represent the coefficient of x squared, going in descending order. This will represent the coefficient of x, and this will be my constant. So here we have 3, 2, 1, 0. My coefficient of x cubed is 1. There will be no x squared. There will be no x, but my constant will read a negative 64. Now we know one of my factors already is x plus 4. We determined that using synthetic division and getting the remainder of 0. However, looking at this binomial, x cubed minus 64, we must train ourselves to recognize when we see a perfect cubed binomial. In this case here, my binomial is a perfect cube because my first term is a perfect cube, and believe it or not, 64 is a perfect cube. Now I know what most of you guys would think. Well, 8 times 8 is 64. Well, in this case, 64 is very special then, because it's also a perfect square. But right now, we're dealing with perfect cubes. So we have to ask ourselves, what was cubed to give me x cubed? And what was cubed to give me 64? Those two numbers will represent my a and my b value in my rule. Okay, so in this case here, x was cubed. That's how we got x cubed. I mean, that's common sense. But in this case, the number 4 was cubed. 4 times 4 gave me 16. but 16 times 4 gave me 64. So right now the value of A would represent, A just represent the first term, would be X, and B in this case would be the number 4. Now, the pattern for factoring perfect cubes is as follows. Take the first term, because it's a minus, we put minus here, the second term. If it was plus, we'll put plus. Times the first term squared plus the first term times the second term plus the second term squared. This is the pattern to factoring perfect cubed binomials. Okay, so my first term in this case here is, that will represent A, is X. Well, the term that will represent B would be the number 4. So we will write my, in parentheses, X minus 4 times my first term squared, so X squared, plus my first term times my second term, X times 4. This will yield 4X plus my second term squared, 4 squared. 4 times 4, 16. And using my pattern, we have just factored my perfect cubed binomial. However, we cannot forget that X plus 4 is also a factor. So my final answer, I will write all factors. In this case, it was X plus 4 as one of my binomials. Then my X minus 4 times my X squared plus 4X plus 16. This would be my final answer, guys. So this is how we show if a binomial is a factor of a polynomial, then how to factor that polynomial completely. I hope you guys enjoyed this video. And if you know Mr. Holmes, you know what I'm about to say. I hope you enjoyed this video and have a blessed day.